Okay, on the assignment we just did, we constructed 3 medians to see where they were going to intersect, and we constructed 3 angle bisectors to see where they were going to intersect. But on our upcoming assessment, we're just going to need to construct 1 median inside of a triangle at a time, or 1 angle bisector inside of a triangle at one time. We don't need to do 3, okay? So looking at the first one, how do we do the construction of a median from vertex C to side AB? So we're only going to have to do a perpendicular bisector on side AB in order to get that midpoint and then connect it to the vertex. So we're going to go straight through right here, circle around A, there's my first circle around B, and then please connect where those two intersect. When we do that, when we create this perpendicular bisector, the whole reason we did this was to get this little point here, the midpoint of side AB. The midpoint of side AB is now going to get connected to vertex C, and that's what makes our median. So how do we know it's a median? We know it is a median because it is connected from the midpoint to the opposite vertex. We know it is the midpoint because of the perpendicular bisector construction. So you're going to have to put reasoning for why you did that construction. Now, if I look at this next one, we use the construction of a rhombus for this one. And then after we do sharp edge here on B, and we get arc, we then move our sharp edge to here and do a new arc, new sharp edge here, new arc, and then we can see that that's where they intersect. What I'm showing here is all 3 full circles. If you're not sure where to do the arcs, just do 3 full circles. Circle around B, circle around new left side point, circle around new right side point, and see where they touch. If we were doing the construction of a rhombus, we would connect all 4 sides, but here we just want the construction of an angle bisector of angle B. So we're just going to connect the diagonal straight out from angle B through the point of intersection, and there's our angle bisector. How do you know that this is an angle bisector? We know this is an angle bisector because the diagonal of a rhombus bisects the angle. That's a property of a rhombus. And so since we did the construction of the rhombus, we can say that. All right, down here next is just the proof. You can do it as flow chart on the test with these given bubbles, or you can actually write your own 2-column or paragraph proof. It's your choice. But if you do the flow chart, one thing that also just came up on the recent quiz is there's a specific way that the givens have to be written flowing into the correct items. So for example, in this one, the givens are written as the parallel lines and then the midpoint. So a lot of students are tempted to just write it in that order, but notice that this flows into a pair of angles right here. So actually, this given, the parallel lines, needs to go here, flowing into the angles. And this given, the midpoint, needs to go here, flowing into the equal sides. So it is important to note what are your givens and what they flow into before you write it. So we're going to go AB is parallel to CD, given, and that gives us that angle C and angle B are congruent by alternate interior angle theorem. Then we can put the other given here. E is the midpoint of BC, given. And if E is the midpoint of BC, it means this little side is equal to this little side. So we can say CE is congruent to BE by definition of midpoint. So that's the part that can be tricky about these flowchart proofs, is you have to be very careful with where things go and what they flow into. Now there's another random angle AEB is congruent to angle DEC. This is a standalone, nothing flowing into it, because this one is just vertical angle theorem, or vertical angles are equal. Now we have enough for congruency by angle side angle. And if you're having trouble seeing what that is, here's my angle, here's my side in between the two angles, and here's my other angle. Sometimes I just write it directly on the proof like that. So we're going to say triangle AEB is congruent to triangle DEC. Now we can say that AE and DE are congruent by CPCTC, or congruent triangles have congruent parts. Either of those work. And then that flows into, now I can say what I was trying to prove, that AD and CB bisect each other. And that is by definition of bisect. How'd you do?